So you have to know only function. Okay. So sulfur, there are two amino acids which are cysteine and methionine. Okay, you can see sulfur. These two amino acids are there. So it is a constituent of several coenzymes, vitamins and coenzymes. Next, we'll go to iron. Plants obtain iron as ferric ions. This we had done. So you can see the change in color of the leaf. This is without Fe deficiency. Means in this there is iron present. Whereas if you remove iron from the soil, the leaf will lose chlorophyll and it will turn yellow. So that's why it is the main constituent of electron transport chain, pyridoxine and cytochromes. Electron transport change. As the electron moves from lower to higher, it will generate ATP. Okay, that ATP generation we will study in chapter photosynthesis. ETC. It activates catalase enzyme and is essential for the formation of chlorophyll. Iron is also essential for formation of chlorophyll. Next, we have manganese. Manganese, where it is present? Manganese. Magnesium is in chlorophyll. It is absorbed as manganose ion. It activates many enzymes involved in photosynthesis, respiration, and nitrogen metabolism. The best defined function is in splitting of water to liberate oxygen during photosynthesis. So this manganese ion is used to liberate oxygen from water during photosynthesis. What is this process called? Photolysis of water. Photolysis of water. Okay. Next is zinc. Plant obtains zinc as zinc ions. It activates various enzymes, especially carboxylase. It is needed for the synthesis of auxin. Auxin is a plant hormone. Will not study all few importance. I'll give you in notes. I'll make notes and send. Copper, it is absorbed as cupric ions. Okay. It is essential for the overall metabolism in plants. If you note, everywhere they are saying metabolism. But like iron, it is associated with some enzymes in redox reaction and is reversibly oxidized from copper plus to copper plus 2. Okay, what is oxidation?
It changes any metal into its oxide.
Yeah, addition of oxygen or removal of hydrogen. Then essential mineral element, we have boron. Function is uptake and use of calcium plus ion, membrane functioning, pollen germination, cell elongation, cell differentiation, carbohydrate translocation. So what is translocation? Carbohydrate translocation. Transport of food from leaf to the different parts of the plant. Then we have molybdenum. Plants obtain it as molybdenate ions. It is compound of many enzymes such as nitrogenase and nitrate reductase. These enzymes participate in nitrogen metabolism. Then chlorine, it is absorbed as chloride ion along with sodium and potassium. It also helps in solute concentration. Just like how the potassium increases the concentration, chlorine also helps to increase the concentration. And the anion-cation balance in the cell. It is essential for water splitting reaction in photosynthesis that leads to oxygen evolution. So which was the first one? Manganese and chlorine. Then deficiency symptoms of essential elements. Deficiency of essential element will cause some retarded plant growth. Okay, retarded plant growth. What is retarded plant growth? The plant will not increase in height. Concentration of essential element below which plant growth is retarded is called as critical concentration. The element is said to be deficient when present below critical concentration. What is critical concentration? Minimum jitna chahiye, like if I say there is 5 gram needed, if the concentration goes below 5 gram, the plant will show deficiency. The plant will show some disease or will show some defect. That minimum amount which is required is called critical concentration, minimum concentration. And if it goes below minimum concentration, then only we will say it is less. If you give 5, 6, 7, 8, okay, but if you go below 5, then it will be less. That is called critical. Okay. If you keep on decreasing the concentration, directly the plant will not show symptom. If you keep on, but at one point it will start showing the symptom. That is called critical concentration. The morphological changes due to deficiency or absence of an element are called as deficiency symptoms. So these 2 points I'll give later. Deficiency symptoms of essential element. Deficiency symptoms vary from element to element. Thank you. It varies from element to element. The plants that show the deficiency symptoms depends on the mobility of the element. Jitna fast the element will move, no? The more it will be easily given to the plant. So if it is very slow moving element, it will show more defects. For elements that are actively mobilized, जो fast move होते हैं, and exported to young developing tissue, and which goes to the young developing tissue, the deficiency symptoms appear first in the older tissue. Older tissue will show the deficiency symptoms first because they are easily going to the new tissues. The young tissue is easily getting, they are going fast. So they will leave the older tissue first and symptoms will be shown in the older tissue. Example, deficiency symptoms of nitrogen, potassium and magnesium are visible first in the senescent leaf. Leaf is the first part which will show you the deficiency symptom. Leaf, because the color of the leaf will change. So deficiency symptoms in older leaves, biomolecules containing these elements are broken down. Okay, in older leaves, biomolecules containing these elements are broken down. It makes these elements available for mobilizing to younger leaves. It is just like your parent will take care of your self. If there is less food, they will stay hungry, but they will see that you don't stay hungry. That is what is happening here. So older leaves, what they will do, they will break the molecule and distribute to the young one. They will die first, but not the young one, because they will continue the generation. Young one. If young one is dead, then entire plant will die. So that is what they are doing. If the elements are relatively immobile, if the element cannot move and are not transported out of mature organ, the deficiency symptoms appear in young leaves. If the element is less mobile, if it is not moving out from the older stem, directly see roots will come in contact first with the older parts. Then as it goes up, on top the parts are young. At the base they are small. So that is what is happening here. What happens if the element is not moving? It will be there with which part? Older part. So young parts will show the symptom first. Okay. There are 15 to 17 elements we are talking. Out of 15 to 17, say 9 are mobilizing fast, 6 are not mobilizing fast. So effect of 9, which are mobilizing fast, are not shown in the younger leaves. They are shown in the older leaves. Effect of the remaining 8, 9 and 8, 17, which are staying with older leaves, which cannot mobilize, which cannot move to the young leaves. That young leaf will show the symptoms first. The aspect of mineral nutrition has a great significance in agriculture and horticulture. So this mineral nutrition is very important in agriculture and horticulture. Therefore, whenever a farmer, if he plans of growing a new plant, first he will do the test of soil. He will try to test what is missing in the soil, what is there more in the soil. Based on that, he will apply the fertilizer or nutrients. Simply, if there is already more nitrogen, if you put more nitrogen, it will show some other effects. secretion level. Now, deficiency symptoms of essential elements. The deficiency symptoms involve chlorosis, necrosis, stunted growth, premature fall of leaves and buds, and inhibition of cell division. So, chlorosis, we have to see what is the definition. Necrosis, stunted growth, and premature. Chlorosis is loss of chlorophyll, leading to yellowing in leaves. It is due to deficiency of N, K, nitrogen, potassium, magnesium, sulfur, iron, manganese, zinc, and molybdenum. Necrosis is death of the tissue. The tissue will turn completely brown. The leaf will completely die. Chlorosis, leaf is turning yellow because of loss of chlorophyll, and necrosis, the leaf dies. But it will start with chlorosis because it will lose, and then sometime it directly dies. So the deficiency due to calcium, magnesium, and copper. Lack of low level of NKS and MO inhibits cell division. Low concentration of NS, MO, etc. delay flowering. Okay. These are some symptoms. There will be delay in flowering. Okay, it will take lot of time to flower. Or very less flowers you will get. Deficiency of different elements may cause same symptoms. Symptoms may be same. Hence, to identify the deficient element, all the symptoms are studied. Also, different plants respond differently to the deficiency of same element. Different plant will respond differently to nitrogen, potassium. Different plants. Not all plants will show the same symptoms. Got no? Then a moderate increase in micronutrient is called as toxicity. Moderate increase in micronutrient is called toxicity. Okay, any mineral ion concentration in tissue that reduces the dry weight of tissue by 10% is considered to be toxic. It will make the plant to grow slow. Such critical concentration vary widely. The toxicity symptoms are difficult to identify. Toxicity levels for an element also varies for different plants. Now let us see micronutrient and macronutrient. What is the first difference? Macronutrient is required in more than 10 millimoles per kg of dry weight. Per kg of dry weight. Micronutrient is required in less than 10%. Now what will happen suddenly if I increase some macronutrient? Will the plant show some extra defect? Macronutrient is third. Okay. Macro I'm talking. Now macronutrients, say if it is rice, sometimes if you eat 2 balls of rice per day, what will happen if I give you 3 balls? Will something will happen much? Will it show some extra effect? Let us take medicine now. Food, let us consider as macronutrient. Medicine, let us consider as micronutrient. Do you take large amount of dose or little dose? Little dose. So if it is 1 tablet per day, okay. By mistake, if you take 2 tablets, what will happen to your body? Will it show more symptoms? So it will show more. It will show more side effects. Or imagine 2 balls of rice and you give 3 balls. Where it will be more symptoms?
If less.
When it is micronutrient, even the master wildland, if there is micronutrient and if you increase the concentration by little amount, the plant will show some side effects. But macronutrient, no, by mistake, if you give more, no, it will adjust. It can adjust. Micronutrient, what is said, it should be given in small amount. So if you give extra, it will show some side effects. Macro, you can, if there is slight change in macronutrient, no harm to the plant. But micronutrient slightly extra or slightly less, it will show some symptoms. It is just like taking insulin. By mistake, if you get more insulin in your body, you will get insulin shock. Okay? Because the complete loss of sugar. So insulin, there will be more use of sugar by the insulin and you can faint. That is what is micro and macro. Got two difference between macro and micro. Macro, first you see what is the quantity. It is required in large amount. Micro is required in less amount. Macro, if we give by mistake extra, the plant will not show much of side effects. But micro, slight increase, the plant may die. Toxicity of micronutrient. Excess of an element may inhibit the uptake of another element. Micronutrient, excess, mass excess दिलो दुसरो घेवचो ना तो. Okay, excess of one element will stop uptake of other element. Excess of some element will stop other. Excess of manganese induces deficiency of Fe, magnesium and calcium. If you put more manganese, no, and if there is iron, magnesium and calcium in the soil, the plant cannot absorb this because this one is competing. This one is Mn is competing with Fe, magnesium and calcium because it competes with Fe, magnesium for uptake and with magnesium for binding with enzyme. Manganese also inhibits calcium translocation in the shoot apex. Thus, symptoms of manganese toxicity may actually be the deficiency symptoms of Fe, Ma, Mg, and Ce. So, if you give more manganese, what you are seeing is deficiency syndrome symptoms of Fe. More manganese you are giving. The symptoms which you are getting is actually what you would have got if you have given less of Fe, magnesium and calcium. Main symptoms of manganese toxicity is appearance of brown spot surrounded by chlorotic veins. What is chlorotic veins?
Which has chlorine.
Which has lost chlorosis. Let's see how much is there. Okay, we'll stop there.